Hello, good afternoon, and thank you. I'm Rafter Ferguson. I'm a scientist in the Food and Environment Program at the Union of Concerned Scientists, and I'm happy to have the opportunity to share a slice of some ongoing work on farmland concentration, farm size, and resilience that my colleagues and I have been working on. The past century has seen dramatic consolidation of farms and farmland, with much larger and many fewer farms, from a peak in 1920 of nearly 6.5 million farms, averaging about 150 acres in size across the country, to just over 2 million farms more recently, averaging nearly 450 acres. This consolidation has been accompanied by huge gains in the productivity of labor and land, largely through the intensification of production, through the replacement of labor with machinery and agrochemical inputs, intense regional specialization, and the simplification of agricultural landscapes to facilitate efficient mechanized cultivation and harvest. So, with these dramatic shifts in the structure and practice of agriculture, we ask what are the implications for the ability of our agricultural system to be resilient in the face of disturbance and change. So, drawing from a recent definition, we define resilient food systems as the capacity of people to produce and access nutritious and culturally acceptable food over time and space in the face of disturbance and change. And, clearly, whether it's climate change or a pandemic, it's really important that efficiency not come at the cost of fragility or vulnerability to disturbance in any aspect of the farming system that we depend on every day. And so here we're focusing in on agriculture rather than the larger food system referenced in the definition above. And so here are some minimal requirements for resilient agriculture: diverse and sustainable practices and landscapes, healthy rural communities, and of course, farmers. Uh, Agriculture needs farmers, and we need generational succession and replacement of farmers over time, like any other industry or sector. And now, this list of minimal requirements isn't intended to be exhaustive, just a bare bones and straightforward one that's hopefully pretty easy to agree on. So, on a general level, there is an ample body of research connecting consolidation with adverse impacts on multiple social and environmental aspects of resilience. So the growth of farms is tightly linked with capital and input intensive monoculture production, with the loss of natural landscapes, with increased pesticide use. Um, and in social terms, we know that mid-sized farms in the US are associated with a more civically engaged middle class, with greater income equality, and with a healthier community social fabric. And similarly, that concentration of farmland has been associated with poverty and inequality in the north central US. So there's this body of research out there that we can draw on for thinking about consolidation and resilience. But when we get down to this third criterion, this very basic fundamental need for farmers, specifically the next generation of farmers, there actually isn't that much to draw on in terms of the connection with farmland consolidation. It's a logical and well-established fact that consolidation is connected with the loss of farmers over the last 100 years. But driving the exit of existing farmers is not necessarily the same as suppressing new farmer entry. But we know that the issue itself is a serious one and well known. The stories have been rolling out regularly for some years now, as year by year the average age of the farming population continues to rise. Agriculture needs farmers, period. And a resilient agricultural system needs to be a welcoming place for a new generation of farmers. So we ask, how is cropland consolidation connected with barriers to new farmers? And so we're interested in describing the extent and distribution of ongoing cropland consolidation in the US at the county level, to explore the relationships between cropland consolidation and, one, farmer age as an indicator of new farmer entry, and two, the cost of farmland per operation as a barrier to entry. So we're drawing on the last 20 years of USDA Census of Agriculture data as well as the data from 1978 to get a sense of longer term and more immediate trends. Looking at crop farms and acres of harvested cropland across farm size classes, as well as farm operation and farmer demographic data, specifically age, and doing some descriptive analysis and visualization and a little bit of regression modeling. So we're focusing on cropland here. Now, acreage is only one way to think about farm size and farm consolidation. You can also look at other kinds of capital or examine consolidation in terms of sales and market share. We focus on land because it's the most fundamental resource and input for farming, and it's frequently cited as a barrier for new farmers. And in this study, we focus on cropland specifically because consolidation is ongoing for cropland, while in recent decades we've seen animal agriculture shift toward smaller acreages. So these maps show changes in the distribution of cropland across farm size classes between 1925 and 1978, so like the sort of bulk of the 20th century, or actually the middle 50 years of the 20th century, and then 1978 to 1997, and then the more recent 20-year period, 1997 to 2017. Counties are colored according to the size class that gained the most acreage across the top row, or lost the most across the bottom row during each of those three intervals. Cool colors indicate the smallest size classes, yellow indicates the largest, and the largest in this case is cropland acres on farms over 1,000 acres in size. So in the last 40 years, we see the hollowing out of US agriculture, with the largest gains consistently to the largest size class, and then in terms of losses along the bottom row, particularly in the last 40 years, the largest losses are coming from the mid-size range, those kind of intermediate, cool cyan colors of 50 to 999 acres. So in the recent decades, we see smaller farms staying relatively static, large farms increasing, and mid-size farms losing. So that look at the change across categories doesn't tell us anything about the state at any given point, so we can look at these two snapshots 4 decades apart. Here we're looking at the percent of harvested cropland in each county that's contained in large farms of over 1,000 acres. So over this period, large farms ballooned in size, collectively absorbed 100 million acres, an area larger than the entire state of California. Mid-sized farms between 50 and 1,000 acres lost nearly the same, nearly 97 million acres, an area itself larger than the entire state of Montana. And so not shown on this map, that loss of mid-sized farm acreage also accompanied the loss of nearly 700,000 mid-sized crop farms. So looking at the regional patterns, we can see these strong regional shifts from the Midwest to almost all points east in terms of increasing acreage in large farms, increasing levels of consolidation, with the exception of some holdout zones in Appalachia and some parts of the Mississippi Delta and coastal New England. And this time frame is important, this last 40 years, because we know that consolidation began in earnest. It really kicked off about 100 years ago, and it hit its fastest rate between 1950 and 1970. And that being said, it's still very much ongoing. Our agricultural system has already been transformed, and the process of transformation continues. So we usually think about the average cost of land per acre. And over the last 40 years, the average value of farmland per acre did increase by 65% even after adjustment for inflation. But that only tells part of the story, and that's not actually what we're looking at right here. Here we're taking the logical connection that larger farms have more land value and investigating the extent and the scale of that pattern. So purple is the lowest, with average farmland value from $30,000 to $300,000 per farm. And that highest level, red, is more than $2 million worth of land per farm. So farmland value per operation, per farm, gives us a sense of the character and context of farming in that area, what a typical farm looks like, and the scale of the barriers that a typical new farmer might face. And we should note that high farmland value can be very good for existing farmers, giving them access to credit, but it's rarely a good thing for new farmers. And even after adjusting for inflation, we can see that the cost of land per farm has increased over most of the country, and the spread of farms working on more than $2 million worth of land is dramatic, particularly in the Corn Belt, Northern Plains, and in Central California. So we can also drill deeper to directly look at the relationship between consolidation and farmland value. Here we're looking only at cropland dominant counties with more than 20,000 acres of cropland and at least twice as much cropland as pasture. So the average cost of farming operations has increased not just from 1978 to 2017, but at every point in between, even after adjusting for inflation. And in counties where the working cropland is concentrated in the largest farms, the cost of farmland rose most dramatically, rising faster than in all other counties. And in a separate piece of analysis, the 10% of counties experiencing the highest rates of farmland consolidation saw farmland value increase by 139% compared to the national average of 71%. And looking at average farmer age, and farmers are getting older nearly everywhere, and especially where consolidation is greatest. So across these cropland dominated counties in this study, we see a consistent increase across the board, as we would expect, but we also see this relationship between consolidation and farmer age emerging over that period. Over the last 10 to 15 years in particular, higher levels of consolidation are accompanied by higher farmer age, suggesting that there's a connection there. So to investigate the relationship between age and consolidation more closely, we took a multi-level modeling approach using average age as a response variable, percent of crop farm acreage and large farms as our predictor of interest, and also controlling for the year, for the population density to account for the effect of the rural-urban gradient, the log of the crop sales per harvested acre to account for soil productivity, and a binary variable indicating agricultural importance. Basically, farms with the top quartile, who are in the top, or I should say, counties that are in the top quartile of crop sales for the country, or the second quartile of crop sales, but the top quartile of sales per acre, are indicated as agriculturally important. And we included another binary variable indicating ERS farming dependent designation, where farm earnings account for an annual average of 25% or more of total earnings in the county, or farm employment accounts for 16% or more of total employment. So the first, agricultural importance, is sort of the significance of the agriculture in that county to the country. And the second, farming dependent, is the significance of agriculture in that county to the residents of that county. And we log transformed population and density and crop sales to bring them into a roughly equivalent scale to the other variables. And the model shows a significant, but shows consolidation as a significant but weak predictor of average farmer age. Strongest predictors being, in descending order, agricultural importance, so counties where agriculture is most important to the country, most economic importance to the country, have older farmers. Sales per acre, so counties with highly productive soil have older farmers. And farming dependence, where counties where agriculture is of most economic importance to the residents have older farmers. So many questions remain here, including whether a different modeling strategy, like modeling rates of change rather than static snapshot variables, or accounting for interactions or nonlinear effects, or using different indicators of new farmer entry, might provide another useful perspective on these relationships. But we know, in conclusion, we know that resilient agriculture needs farmers. We know that we have uh, a crisis of succession and generational replacement in farming. And there is evidence that points towards cropland consolidation working against resilience in multiple ways, including limiting access to land for new farmers. And most importantly, we can act now to support new farmers while we continue working to better understand the barriers that they face and the needed solutions. Thank you. Um, to stay connected to Union of Concerned Scientists, you can text food justice to 662-266. And I look forward to taking questions. Thank you.